Okay, so we have the elasticity of demand, and we have a problem here, and we are going to solve it. So I actually haven't written out the problem. I'll put that in right now. Okay, so given a demand function, P equals 69 minus 3Q, find the price elasticity of demand when P equals 46. So we have our demand function, inverse demand function. Our P equal to 46 is what the part of the problem. And the elasticity of demand, this is the general formula for it, where you have the dq over dp times p over q. Or the change in quantity divided by the change in price times the price, the ratio of the price and quantity. So in order to solve this, we need to find P and Q. We have P here, but it's in terms of Q, we have to find Q. So in order to find Q, we are going to have to solve this inverse demand function for Q. And so you have moving 3Q over to this side and transposing the P over there. And dividing each term by 3. I'll do it over here. Q is going to, oh god, Q is going to equal 23 minus 1/3 P. So now we have our I'm so bad at drawing boxes. I should just leave it. So now we have our Q in terms of P, and we know what P is. It is 46. But before we do that, we have the elasticity of demand, where we have to take the derivative of Q with respect to P. That is also a good reason to solve the inverse demand function for Q. Because in order to solve the elasticity of demand, you need to take the derivative with respect to P. And you can't do that when it's in respect to Q within the inverse demand function. So taking that, so derivative of a constant is 0, derivative of P is 1 using the power rule. That 1 comes down there, 0, P equals 1, it's no longer a variable. 1 times 1 over 3, well, times negative 1 over 3 is negative 1 over 3. And that's just called the power rule. So you're left with 1 over 3. Multiplying through by P, which is 46, that is given. And then we have to solve for Q by plugging 46 into that. So you'll have Q constant, and P is 46 over 1, which equals 23. I'll do it underneath. 46 divided by 3. Simplifying a bit further. $7.67. And plugging that, plugging that into the elasticity of demand. Formula. And then solving. You will get 46 over 3 times 7.67 is 23. Technically 23.01. And that will equal -2. And taking the absolute value of that, you are left with 2. So the elasticity of demand is equal to 2, which means that you have a elastic product, and it is a substitute. So that when the price increases by 1%, quantity demanded decreases by 2%. So people will substitute your product for something different due to the elasticity. Graphing this, your demand will be quite flat or flatter. It will not be that. If you want to have a look at this further, you can look at this graph here where you have the elasticity coefficient, where it is inelastic if the elasticity of demand is between 0 and 1, and it is elastic when it is greater than 1 and less than infinity, obviously, but yeah. And looking at it here further, this is not the scale, this is just kind of made up the numbers. You can see this graphed in terms of what happens to revenue and your price and your quantity. So starting off, you have your unit elastic is 1, which means whatever percentage change in quantity is the percentage change in price, or percentage change in price. If price changes, goes down by 10%, your quantity demanded will rise by that same value. That is what is unit elastic, and unit elastic is equal to 1. Anything less than that is inelastic. So from this portion starting there, you'll get what's called elastic. So if you're up here, B1 and B2, B1 price is set at 50. If it decreases, by $5, that's a change of $5, but the quantity demanded will shift outwards due to the demand properties. Where if your price goes down, people demand more. You will get an increase of 20 units. And coming down here to see that in action, RB1, you have revenue of $5,000 with the price of 50 and 100 units, and you drop your price to 45. You end up selling 120 units, you get a increased revenue of $400. That means your revenue will increase by 8%. And the elasticity, you have the percentage change in quantity over the percentage change in price equals -20 over 10, and you get a -2. You take the absolute value, so that negative kind of cancels out, and you just get 2. And from what we saw up here, if elasticity is the coefficient, elasticity coefficient is greater than 1, so if 1 is less than, you have an elastic product, which means you have a substitute. And that makes sense because the higher you are in price, the less the percentage change is going to be. So that they've been subtracted by the same nominal amount, $5, but $5 taken from 10 is a 50% change, whereas it is only a 20% change, 10% change in price from 50 to 45. That's only 10%. Whereas if you move down in price, you get a greater percentage change, which will affect your demand, your elasticity, sorry. Okay. But seeing that down here, you have your price change of from 10 to 5. So that will be a deduction. Let's change this color to pink or magenta. I guess you can cross color. And that will increase your quantity demanded. But because it has to do with the left and right side of the parabola, if you haven't noticed. So the left hand side, which is what this is trying to denote, the left hand side of the parabola, you'll have inelastic demand, which means your revenue will increase via a price decrease. You can see it at universities where they might have discounts for students after a certain time period. That is strategic in a sense that they're using the elasticity of students' budgets, where every product is essentially elastic because uni students don't earn too much income because they're studying, right? So if you have a coffee valued at $6 and then after a certain time period you value that coffee at $2.50 or $3, your quantity demanded will go up quite drastically due to the elasticity of demand for that coffee. And they want coffee because they want to study and stay awake. If that makes sense. I don't know if I explained that properly. Okay, so this is university coffee. You have your total revenue curve, your demand curve, and the prices and respective quantities, right? And if you look on the right hand side of the demand curve, the linear demand curve, it's just a straight line, it's elastic. At the point in the middle, unit elasticity is 1. Anything to the right of that is elastic. Anything to the left of that is inelastic. And we're looking at a university charging prices for a coffee and the respective quantity demanded at those prices, and how this equates to revenue. So you have $6 with 200 units. 200 units of coffee. Okay. This is not touch friendly. And that after 2 o'clock, that drops down to $2.50 per coffee. Now that is a drastic price decrease. And respectively, that is a drastic price decrease. And the resulting quantity demanded at that price is 800 units. So 800 units of coffee. And you've noticed we've crossed over. So this is a parabola, the shape, so it'll be x squared. But that's your total revenue curve, right? That is now in the elastic side of the demand. So you're getting everyone that's elastic for their prices of coffee, or views coffee as an elastic product, which is for sure uni students. Uni students, almost everything is elastic for a university student, given that they're not just getting a unsurmountable not income, but what's the word? I haven't had it in a long time. Allowance. That's the one. Given their parents just aren't giving them a bunch of money. And if you look at what happens when you do the equation for elasticity of demand, you have the percentage change in quantity, all divided by the percentage change in price. So the percentage change in quantity from 200 to 800 is a 300% increase in quantity demanded, all divided by a 58.33% decrease in price. There is a negative there, but for elasticity of demand, you take the absolute value, and you get an elasticity of demand of 5.14. Elasticity of demand is greater than 1, or price elasticity, which means it is elastic, which is what you would expect when you're serving coffee at a university with such a decrease in price. So you could implement that through a policy, right? So okay, I won't get into that. But this could be a policy, say, it's a happy hour, essentially. So when places have happy hour, they're trying to boost their revenue for that hour because they're trying to drive the quantity up. Business might typically be slow at that times, and they're trying to incentivize people through a price decrease to purchase more of that. I'm not sure how that works in case everyone just waits till happy hour and they get flooded, and that might you have to add extra labor costs, and that might actually be detrimental in the long run, who knows. But anyway, let's look at the revenue of what this coffee shop will get, respective of prices. So they were having an inelastic price and quantity for their revenue one. Just you have $6 times 200, you get $1,200 of revenue. And then after 2:30, they drop every coffee to $2.50, and they have 800 patrons come through. They are increasing their revenue up to $2,000. So that is a $800 increase in revenue. Percentage wise, percentage change in revenue, you would have, there won't be enough room, I'll just do it underneath. 100 multiplied, oh god, the final minus the initial divided by the initial. Plugging that in. They increased their revenue by 66.67% due to that policy. It's a pretty good increase in revenue throughout the day. But that is how you would use price elasticity of demand for something that makes sense, and you can demonstrate it.